Let us discuss in detail about normal reaction. As we have studied, we can once again write down. It is a force which exists when two bodies are in contact and one out of these two bodies pushes the other. Obviously, when one body will push the other will also react it. So, an action reaction contact force is developed, which we term as normal reaction. We can also write another point about this normal reaction, that it always acts in the direction normal to the surfaces in contact. It always acts in the direction perpendicular to the surfaces in contact. Like for a simple application, we can directly state, if on ground a block is placed, it will experience mg in downward direction, and due to mg the block will push the ground with the force N and ground will react with the same force N. So this is the normal reaction which exists only if mg is there. If mg will not be there, the body will not push the ground and ground will not react the body. Here if we draw free body diagram of body, we can simply write, considering this body as a point, it is experiencing one force mg in downward direction, and another force which is experienced by the body is this upward N. So we draw this N only in the free body diagram of body. We are not going to draw this normal reaction in free body diagram of body because this is not the force which is acting on body. It is applied by body on ground. So be careful whenever we draw free body diagrams, we draw only those forces which are acting on that body of which we are drawing the free body diagram. To understand the normal reaction, let's take up an example. Here we are required to show all the forces acting on the block and rod in their free body diagrams. We just have a look on the basic forces acting on the block as well as on the rod. You can see due to the weight, the block will push the ground, say with the force N1. So ground will react the block with the same force N1. And the rod, again due to its weight, it is pushing ground at this point with a force N2. Ground will react it with a force N2, and this will be perpendicular to the contact surface that is of ground. Here you can see for rod there is just a point in contact, the surface is that of ground, and always the normal reaction act in the direction perpendicular to contact surface. Similarly, at this point of contact, due to the weight, rod will be pushing the block. The surface is that of rod, and for the block there is only one point in contact, so the normal reaction N3 will act in a direction perpendicular to the contact surface, which is that of the rod. We just draw the free body diagram of M1. Here you can see it will experience a downward weight M1G. It will experience a normal reaction N1 in upward direction. It will also experience the normal reaction N3 which is applied by rod on the block. If this angle is theta, we can also consider this as theta. So here the normal reaction N3 will be acting at an angle theta with the vertical. So here if we resolve the forces, N3 cos theta will be acting in vertical direction, and in horizontal direction it will be N3 sin theta. So this is the free body diagram of block M1. If we draw the free body diagram of M2, that is of rod. On rod we can again say, we consider it as a point mass. In downward direction it will experience the force M2G. One normal reaction by the ground will be acting on it in upward direction, that is N2. The third normal reaction N3 will act on the rod in a direction perpendicular to the rod, this is N3, which is making an angle certainly theta with a vertical like this. So again we resolve this N3 in the two directions. This will be N3 sin theta, and in upward direction it will be plus N3 cos theta. So this is the free body diagram of the rod which is of mass M2. Very carefully you just have a look on free body diagrams, because later we are going to discuss the applications of Newton's laws using these free body diagrams. Further, for normal reaction, you just write down a note. This is very useful while handling different problems. In case of a circular, spherical or cylindrical object, normal reaction always pass through the center of object. As we have studied that normal reaction always act in the direction perpendicular to the surface. So in case of circular, spherical or cylindrical object, at any point if we draw a normal, it must pass through the center of object. Like for a simple example, we are having a step and say there is a cylindrical object. It is pulled by a boy in opposite direction like this. He is applying a force. Due to this force, the string will get tensed and say a tension T is developed. He is trying to lift the object above this particular step. Now in this situation we can say at bottom normal reaction N1 would be acting, it must pass through the center, as well as at this point due to the pulling effect of tension, this cylindrical object will push the corner of this step, due to which a normal reaction N2 is developed over here, and as it is perpendicular to the tangential surface of cylinder, it must also pass through the center. So obviously an opposite reaction N2 will act in this direction and reaction of N1 will act in this direction. So if we draw the free body diagram of this cylindrical object, if we just draw the free body diagram of cylinder, you can simply write in downward direction it will experience mg, in upward direction it is having a force N1, toward right it is experiencing the tension T, and one force N2 is acting in this direction. If this angle is theta, from horizontal this N2 will act at an angle theta. So here we can say this N2 will be acting at an angle theta. If we wish, we can resolve this N2 in this direction, it will be N2 cos theta, and here it will be plus N2 sin theta. So this is the complete free body diagram of this block. So be careful about such type of cases whenever a circular or cylindrical object are in contact at some point and a normal reaction acts. So normal reaction must always pass through the center. Another example we can also take up, say if there are two edges or corners, and at these edges or corners say a spherical ball is supported. In such situations we can say at this point the normal reaction N1 will act in this direction, opposite will also be acting and it must pass through the center. At the other point also N2 will act in this direction like this. So here we can state N1 and N2, which are the contact forces or normal reactions acting at these points. They must pass through the center. If we just draw the free body diagram of this object in downward direction, it will be experiencing mg. And say if they are acting at an angle theta 1 and theta 2 from horizontal, you can say here N1 will be acting at an angle theta 1 with the horizontal and N2 will be acting at an angle theta 2 from the horizontal. And further, if we wish, we can resolve these forces, and this will be the free body diagram of this ball. We can write this as FBD of ball. So be careful whenever you draw free body diagram of circular, spherical or cylindrical objects. Always remember that the normal reaction acting at any point must pass through the center of the object.